The next SQL statement we're going to analyze, similar to the previous one, it's a two-table join. We're joining the history table, the teller table. The two tables are joined on the teller ID columns from each. One difference here is that instead of returning full joined rows, we have a group by function. So we're going to group by teller ID and teller name. So the idea is we're producing a summed balance from transactions by teller ID, just the total of the balances from each transaction rather than an individual transaction by transaction result. We've assigned the database connection, and we'll open Visual Explain, taking the defaults for the access plan generation. Maximize our graphical explain view. Similarly, we have a hash join now being used to combine the two tables. Access to the history table is through a table scan. So the history table again has 200,000 rows. The table scan is estimated to produce about 20,000. So there's a couple predicates being applied in this table scan. One predicate is the teller ID is less than or equal to 200. The other predicate is the teller ID is greater than or equal to 100. So it's a range of 100 tellers. So that's why we go from 200,000 to about 20,000, so about 10%. We're using a hash join. The join is based on the teller IDs being equal. With the hash join, our teller table will be accessed first through an index scan. The index scan shows a predicate of, similarly to the history table, teller ID is greater than or equal to 100, less than or equal to 200. So same range of teller IDs. We look at the costs. The cost estimated for this table scan is $36.78. We look at I/O cost of the table scan is $35.12. Again, we're doing a physical scan of the table. But first we're going to process these rows from the teller table at a pretty small cost. So to fetch the 100 tellers of information, that cumulative cost is just under 30. So obviously the cost of the table scan is 3,600, so 100 times more. The cost at the join, the hash join, is $37.09. So it's a cumulative cost again of time runs, most of that coming from the table scan. The operation following the join is a group by, but we actually, if you look at the access plan, you'll see two group bys. The first group by, the aggregation mode, is hashed partial. So the idea is to produce a partial grouping function as early as possible into the access plan. The final group by occurs here late in the access plan. The idea of grouping them as early as possible reduces the number of rows. So by grouping them, the cardinality now is estimated at under 100. So it goes from being 20,000 here, 20,000 at the join, to 95. So summarizing that quickly, reduce the cost of performing the sort. So the overall cost here of 3717. Most of that has already been accumulated by the hash join, and the majority of that coming from the table scan. Let's take a look at how the access plan would change if we use our alternate table, the compressed history table. So we can just edit the query, re-explain it. We'll maximize that. So now we see the tables being joined by still a hash join. Let's move this down. We could zoom in a bit if we wanted to. Looking down here, so now the access to the history table is through an index scan. And we have a teller index, so it provides a very efficient mechanism for accessing a range of teller IDs. In this case, there is a list prefetch, so it's an index scan, sort, and RID scan. So the fetch of these 20,000 rows from the history table, the cost of now is under 300. So much less. Access this copy of the table. Access to the teller table is the same as before. Again, it's a hash join, so it'll process the entries from the teller table first, store them into sort memory, and perform the hash join. So we're joining the 20,000 entries from the history transactions with the teller data. Again, we do the partial group by after that. So it's the hashed partial. Then followed by a sort, table scan being scanning the sorted result, and then a final group by. The overall cost here of 337, so much less. IO cost estimated at 195. A couple things we could do. Data Studio, Visual Explain, I can reverse the diagram. So if you prefer to view the access plan as a top-down instead of a bottom-up, this just reverses the sequence. So now the initial processing appears at the top of the access plan diagram. It performs the same operation. It's just a different view. You might find it easier to work with or more understandable, and we can do that. Again, we can do the zoom in. If we have a portion of it we want to make larger. If you have a large number of tables being joined, so like a 10 table join, this access plan could get very compressed. You might want to zoom it out to look at more detail of particular operations.